x squared plus x over 3x squared plus 3x. So I see a polynomial looking in the denominator, so I want to think about factoring that. Anytime you see a polynomial that isn't matching on both fractions, you want to think factor that. So let's factor the 3x squared plus 3x. GCF 3x, and we'll leave us x plus 1, right? Okay, so this one, we got a 3x on that and an x plus 1. So this is no longer the denominator. It's now written like that. And we got a 9x squared over here. Go to find the least common denominator. What do they have in common? How? That's good. That 9x squared is actually 3x times 3x. That's right. Okay? So we have a 3x in common. That's one of them. What do they not have in common? The x plus 1 over here definitely is not on this one, right? But this one has how many 3x's? 2 of them. This one only has 1. It's got to have 2 to be the same, right? So I need another 3x and an x plus 1. So my least common denominator is going to be 9x squared times x plus 1. And I'm just multiplying that back together to show, hey, that's actually what this one already had, which is going to help me when I go to fix it. Okay, I had one 3x here, 9x squared, y'all told me came from 3x times 3x. So there's 2 of them here. They only can share 1. So 3x times 3x and 3x, there's only 1 that's shared. So that's why we got to have 2 of them, because there's an extra on this first fraction. Okay, got to have 1 representative from each factor. Okay, so what does the first fraction even need? It just needs the x plus 1. It already had both of the 3x's, the 9x squared. So I'm going to multiply bottom times x plus 1, top times x plus 1. What does the second fraction need?
3x.
It needs another 3x to work there. Okay. And then that's going to give me 7x plus 7 over, I'm just going to rewrite it as 9x squared x plus 1 plus 3x squared over 9x squared x plus 1. Okay, then we go to see if we can add those together. It doesn't have any like terms. So I'm just going to rewrite it as 3x squared plus 7x plus 7 over 9x squared x plus 1. There's the trinomial in the top now. So I'm going to try to factor that using the x method, right? So multiply to be 21 and add to be 7. Does anything do that? No. 7 and 3 is adding to be 10, so that's not going to work. So that doesn't even factor, so that means I can't simplify it. And that's my final answer on that. Okay. All right, let's do another one here. X plus 3 over x plus 4, x minus 1. Minus 2x minus 5 over x plus 2, x plus 4. Let's see if we can get that common denominator. What's the first part of the common denominator? X plus 4. The part that they have that's the same. So that's going to be those 2 pieces. Okay. Now, what do they have that's not the same? An x minus 1 and an x plus 2. So the least common denominator is going to be the product of all 3 of those. We're not going to have to multiply that out. That's, don't think I got to multiply that whole thing out and get a cubic polynomial. No, you don't. So what does the first fraction need? Needs an x plus 2. So I'm going to multiply by x plus 2 on the bottom and x plus 2 on the top. Okay? What does the second fraction have missing? X minus 1. So I'm multiplying by x minus 1 on the bottom and x minus 1 on the top. Okay? So, got to have a representative from every factor. The shared one only has to show up once because it's in both of them already. So that's why there's the x plus 4 and then an x minus 1 and an x plus 2. So that's a representative from every factor in the least common denominator. You do have to multiply out the numerators. Now, we don't have to multiply out the denominator, but we do need to multiply out the numerators because we're probably going to have like terms that we can put together with that subtraction that's happening up there. So x plus 2 times x plus 3 would be x squared plus 5x plus 6 over that common denominator. And I'm just going to write it like I did over there. Minus, and then I'm multiplying out 2x minus 5 times x minus 1. That'd be 2x squared minus 2x minus 5x be minus 7x minus 5. And then the bottom part's x plus 4, x minus 1, x plus 2. Now let's do the easy math, the subtraction. Which unfortunately is where most people make mistakes. What's it going to be? Negative x squared. Most people get that part right. Why is it plus 12x? Minus a negative. So it's 5x minus negative 7 is plus 12x. Good. 6 minus negative 5 would be plus 11. And I made a sign mistake. That's actually a plus 5. That is a plus 5 right there. No, that's all right. Go ahead if you see it. I was wrong. I wrote it on the paper. So that would, instead of being plus 11, would be plus 1. There. Sign mistake. And then if we try to do X method on that, negative 1 and add to be 12, we know there's nothing that can do that. So we know that we're not going to have to do any work to simplify that one because it's just not going to. Because we know X method won't work. Like, yeah, go ahead. I got too much to do. All right, let's look at K. So we had x plus 1 over x squared plus 4x plus 4 minus 6 over x squared minus 4. All right. What do the denominators tell us to do?
Well, the right one can factor.
Okay, the right one can factor because it's a difference of squares. Yeah, x plus 2, x minus 2. Okay, so will the left one factor?
Yes,
Okay, multiply to be 4, add to be 4 would be x plus 2 and another x plus 2, right? So those are the denominators we're looking at now to find our least common denominator. What do they share? How many of them? They share one of them. But we need another one because the first fraction has 2 of them, right? So we got to have another one of those. And it needs an x minus 2 because the second fraction has that. So when I write my least common denominator, I'm going to write it like this. X plus 2 squared and then x minus 2 because that's the same thing. It's just shorter to write. So that's what I'm going to do. All right, so what does the first fraction need? It needs an x minus 2. So I'm multiplying it, that top, by x minus 2. The second fraction needs another x plus 2. That's where those are coming from. And so that's going to give me denominator of x plus 2 squared, x minus 2. And then the numerator there is going to be x squared minus x minus 2. Minus, and then it'll be 6x plus 12. And then we have x plus 2 squared, x minus 2. So all that stuff, and we hadn't done any of the math to get the problem done yet. Just getting it ready to work. Let's subtract the numerators. So x squared minus x minus 2 minus 6x plus 12. So that's going to give us x squared negative x minus 6x would be minus 7x. Negative 2 minus 12 would be minus 14 over x plus 2 squared, x minus 2. Do we know anything that multiplies to be 14, negative 14, and adds to be negative 7? No. 14 and 1 are the only options, or 7 and 2. Neither of those are going to get us a negative 7 with the x method. So we're thinking anytime we got a trinomial x method to simplify, it doesn't work on that one, so we're not able to simplify on that one. Okay. Anytime you see a polynomial in the denominator, factor. That helps you build the LCDs. Okay, so you got to build that least common denominator. Once you get the least common denominator,